Hi, Assalamualaikum, and good day to everyone. So today we are going to continue our lecture with the title of Arduino Programming Basics, which today in today's class we are going to concentrate on our first lab, which is the digital I/O. So what is digital input and output? So digital input, it says that if the digital input or if the digital port detects a voltage that is greater or lower certain threshold value, it will give value 1 or 0. Okay, what does it mean? So if the voltage is higher than some value, for example, if the voltage is higher than the threshold value that has been set in the Arduino program, so the computer will detect that value as the high value, or it will be set to 1. Okay, otherwise it will be set to low value or 0 value. Okay, for example, if the detect pin at the digital port detects a voltage that is higher than 4.0 volt, okay, so it will interpret this signal as the high input signal, which in your Arduino program it will return detect is equivalent to 1. Okay, or if the detect pin at this digital port receive a signal or receive a voltage input that is lower than certain threshold value, for example in this case 1.0 voltage, it will interpret that signal as a low input, and detect will return value 0 at your Arduino program. Okay, I hope you can get the idea of detecting the value at the digital pin according to the threshold value that has been set in the Arduino microcontroller board. Okay, this is just example. Okay, so if you want to have a further value of that voltage, you can always refer to the Arduino microcontroller board datasheet. Okay, so there are few types of inputs that can be given to your Arduino controller. For example, like switches and buttons, which will give you value 1 or 0, or a digital input sensor modules. Okay, this is a sensor module. For example, like if you have a digital input IR sensor, which only will detect when there is a obstacle, when there is an obstacle in front of that robot. So when it detects there is an obstacle, it will give value 1. Otherwise, it will give value 0. So it will give only two discrete value, which is 1 or 0. Okay, that is digital input. It cannot give any value that is in between 0 to 1. Okay, for example, like 0.5, 0.9. No, it will give you solid value either 1 or 0. Okay, so this is the basic principle that has been implemented on this digital pin input. Either, okay, from this basic principle, for example, if you push a button, okay, or if you press a button, will you get logic 0 or you will get logic 1? Okay, right? So, and then how about the connection? Okay, so these two things are actually related to one another. Okay, we see in detail. Okay, so we have two resistors type, which is pull down resistor and pull up resistor, or pull down switch or pull up switch. Okay, these two behaviors at the digital pin is actually depends on what logic that you want when you press the button. If you want to have a if let's say if you want to have logic 1 when you press the button, you can always use pull down resistor. Okay, if you want to have a logic 0 when you press the button, you can use pull up resistor. Okay, why? Okay, we look into further. I will explain you in detail. So during the pull down switch explanation, okay, when you have a pull down switch, okay, this is the switch. Okay, when you press this switch, it will close the circuit. Okay, and then the current will flow into this direction. Okay, and therefore the value of V node here, which is your output value, is 5 volt, or logic 1 is appeared. Okay, so let's say that you are connecting your Arduino pin here at V node. Okay, so when you press the button, if you're using the pull down switch, when you press the button, you will get logic 1, or the voltage here will be output 5 volt. Okay, so that is pull down switch. But how about pull up switch? Pull up switch. So during the pull up switch, when the switch is pressed, okay, the current will flow from your input voltage or your VCC towards the ground. Okay, because in the pull up switch, as you can see, the resistor is located or has been placed direct with the VCC. Okay, so it will create more tension here. Okay, so the resistance here is higher, and therefore the current will flow from here towards ground, and therefore the current is pulled to ground, and the logic here at V node is equivalent to 0 volt or logic 0. Okay, can you see the difference? If we look into the pull down switch, okay, here when you press the button or you press the switch, so the current will flow from VCC to V node, because here the resistance is higher, and therefore the current will flow to any output or any exit that has less resistance value. That's why you get V node here equivalent to 5 volt, or when you use this type of switch, you are going to have a logic 1 when the button is pressed. But in pull up resistor or pull up switch, when the button is pressed, okay, as the current is flowing from the VCC to ground, directly to ground, because at the ground the resistance is low, and therefore the V node here is going to be logic 0 or 0 voltage here. So actually that one is depending on the circuit that you have chosen. If you want to have a logic 1 when the button is pressed, then you need to use pull down switch. Okay, if you want to have a logic 0 when you press the button, okay, so this one, so you have to use the pull up switch. Okay, okay, and therefore normally we call pull down resistor as the active high input, because it gives you logic 1 when you press the switch, while on the other hand, the pull up resistor or pull up switch is normally known as the active low input, because when you press the button you will get logic 0. So this is the difference between pull down and pull up. Okay, so now we move to the digital output. So what is digital output? Okay, digital output is normally allows you to control a voltage with the computer. Okay, however, the output voltage is normally between 5 or 3.3 volts. If you're using a TTL system or TTL pin, it will give you 5 volt, for example like Arduino microcontroller, or otherwise if you're using a CMOS technology, it will give you 3.3 volt. Okay, but in our case, since we are using Arduino, so Arduino will generate 0 or 5 volt only at the digital output pin. Okay, if the computer instruct the output to be low, it is connected to ground and produce no voltage. Okay, for example, these are the example of the output that you can generate through the digital output. Okay, for example like motor driver. Okay, you're going to give value 1 and 0 to your motor. So when your motor receive 1, so it will start to move. When the motor receives 0 value, it will stop. That is example. Okay, or maybe indicator lamp. Okay, when you connect your Arduino with your LED, so when you give output 1, so your LED will be illuminated. Okay, otherwise if you give value 0 to your LED, so your LED will be turned off. Okay. Okay, this is an example of the digital output. Okay, let's say you have an Arduino here, and then this Arduino is connected to the LED. Okay, and then the connected pin is 13. Okay, so the digital port 13 is declared as the output or digital output. Okay, if you want to turn on the LED, the digital port 13, you must be set to high. Okay, so when it is set to high, so the output voltage here is 5 volt, and therefore the LED will be on. Okay, otherwise if you want to turn off the LED, you must set the digital value at the port 13 as low value, or you have to give 0. So when you give low value, so there is no voltage output, or voltage output 0 will be produced here, and therefore it will turn off the LED. Okay, so this is the process of digital output that can be used to turn on or turn off your actuator, for example like LED. Okay. Okay. So now we look into the programming syntax in your Arduino program. Okay, we have few types syntax that we can use when we are using the digital port. The first one is the pin mode. Okay, so in the pin mode, you have to configure your digital port to be input or output. Okay, you have to specify that one. Okay, so the pin here is the pin number which you can choose from pin 0 until pin 13. Okay, and then this is the mode that you can put here. Either you want to treat that pin as input, output, or input pull up. Okay, the second one is the digital read pin function. So it will read the value from a specified digital pin, either high or low. Okay, you have to remember, when you read value from the digital pin, you will only get two values. The first one is high or low value. Okay, so the pin here is the number of the digital pin that you want to read. Okay, and then you return this value into integer variable. Okay, and then the last one is the digital write pin value. So in the digital write pin value, you can write a high or low value to that digital pin. So pin is the pin number, value either high or low. Okay, now we look into the example. Okay, for example, in pin mode, okay, as you know that pin mode is used to configure your digital pin. So you can configure it as the input, output, or pull up, or input pull up. So this is the example. Okay, let's say in the void setup, okay, you want to declare your pin 8 as output. Okay, so pin 8 is your digital pin 8, and then you want to declare pin 7 as an input, which you set the digital pin 7 as input. Okay, this is how you use this function of pin mode. Okay. Okay, the second function that can you use in the digital pin is the digital read pin, where you can read the value from that digital pin. Okay, so this is the example. Okay, you have to declare a variable, and then this variable you have to declare by specify it as an integer variable. Okay, so this variable is used to receive data from the digital port where the digital sensor is connected. Okay, so in your void setup, you need to declare one digital pin or one digital port as an input, because you want to connect the digital sensor at this pin. Okay, pin 7. So in your loop function, when you want to read the data at the pin 7, so you have to use this variable, which is you declare as an integer read sensor, and you equivalent with the digital read 7. So it will read data at port number 7. Okay, so any data that it receives from this port or from port 7, it will save into this variable. That's why when you use the digital read, you must have one variable that you declare as an integer, because it wants to save the data that you receive from this port. Okay, So now the third function is digital write. So digital write, as implies by its name, you can write any value to that digital pin, but that value that you can write is only high or low. Okay, so for example, in this case, so you have a LED pin 13. So you set this pin 13 as the output. Okay, and then you can set this value at pin 13 as high or low by using the function of digital write. Okay, so hopefully you know how to write a code using the digital pin port. Okay, you can use three functions. First, you can use pin mode. Okay, pin mode is compulsory. Okay, because you need to specify, you need to tell the Arduino whether you want to treat that pin as input or output. Second, if you want to read data from that digital port, you have to use digital read. Okay, and then you have to save the data that you receive from that port into one integer variable. That is digital read pin. But in digital write pin, you can straight away write value high or low to that digital pin, right? Okay, all right. So you have three assignments, which is your individual assignment. So meaning that each of you need to submit this lab report. Okay, so you have three lab report. So the first lab is LED output without delay. So you write this code and then you see the output of your simulation. So you are going to do all this lab by using Tinkercad. Okay, so I have shown you how to use the Tinkercad from previous slide, so you just implement it. So that is lab 1. So in lab 2, you are going to use the same circuit, but you add delay at in between the code. Okay, and then you observe the output. Okay, and lab 3, you are going to use a serial monitor as the input and output for your digital port. Okay, so you just write this code, and then you see what are the output that you can observe from your serial monitor window. Okay, so in the next video, I will show you how to use the serial monitor function from the Tinkercad. Okay, see you again. Oh, before I forget, you need to submit the report to me. So I will give you instruction how to submit the report, and please follow the instruction. Okay, thank you. So we are going to start the Tinkercad for our first lab. So in this tutorial, I will guide you how to use the Arduino, and then how to write the Arduino code, and then how to send data or receive data through serial monitor. Okay, so so let's say you have a Arduino circuit like this. Okay, you have an LED. This is for lab 1. Okay, and for example, in your lab 1, you need to connect your LED with pin 13, and then you have lab 1, lab 2, and lab 3. So lab 1 is you want to see the output of the LED blinking by using non-delay technique. And then the second lab is you add delay in your code, and then you see the outcome. And then the third lab is you need to send data through your serial port, and then you publish the data at your serial port. Okay, so I just want to share you how to write the code. Okay, so you make sure that you have the correct circuit, and then you connect the circuit correctly. Okay, make sure you are connecting to the right port. Okay, and then the anode and cathode, make sure you have a right connection with the Arduino board. Okay, so the cathode is the negative, is the negative port of the LED, so you have to connect it to the ground port. Okay, and then while the positive anode, you need to connect to the pin 13. So the resistor here is used to limit the voltage coming out from this port to LED, because in practical, okay, LED is only requires around 0.7 volt. Okay, so the output voltage that coming out from this digital port is approximately 4 to 5 volt, and therefore we need a resistor to reduce the voltage that can be supplied to the LED. Okay, but in practical, if you supply a higher voltage to the LED, you actually can make the LED shorter its lifespan. Okay, because it's going to be too hot, and then you are going to burn the LED. Okay, so I have my circuit here. So let's see the code. So when you open up the code is actually readily built for you, so you can change it. Okay, so for example, if let's say I would like to change this one to different port, maybe I want to use port 9 here. Okay, so I connect to port 9 here. So at my Arduino code, I can actually, this one I can change to 9. Okay, because I'm using port LED 9. Sorry, I'm using the digital port 9 right now. Okay, but actually this number 9 you can replace with a variable. Okay, how to replace it? You can declare one integer variable, for example like red LED. So I declare it as a red LED, and then you put that the red LED is going to be connected to pin number 9, so you put 9 here. Okay, and then this variable you can replace it here. It's just the same method. If you are going to declare it directly to port 9, or you can declare it by using a variable. Okay, so the declaration of pin mode must be put at the void setup function. Okay, because you're going to declare this pin as an output once in your programming code. Okay, so the looping function here is going to loop your programming over and over again until you stop the operation of the Arduino. Okay, so this is basically your pin, your lab 2, right? Because you have to put delay in between your LED high and low. Okay, so because I have using the variable red LED here, and therefore I need to replace all the pin number here with the variable that I used. Okay, Arduino is a case sensitive code, programming code, so make sure that if you're using the small letter here, make sure all the variables that you are using, the same variables that you're going to use in your code, must match the original declaration. If you're using a small letter, you use a small letter. Okay, alright, so I believe that this is the code is ready. Okay, this is lab 1, but experiment number 2. So after you have done, you completed the code writing, you can start your simulation and then see. Okay, and you observe. Okay, now you can see the LED is blinking. So this one, so the output you need to capture, and you need to discuss in your lab report. Okay, and then the text code here is you need to give your code in your report, and you also need to draw the flowchart of your code. Okay, so how to draw the flowchart? You can use the link that I have given to you. You can refer to that link. Okay, but if I have some time, I will show you how to draw the flowchart for this code. Okay, later. Alright, So this is experiment B in lab 1. So what if I want to receive data from the serial monitor, and I would like to display the data on the serial monitor. So from this windows, the serial monitor is located here, okay, at the bottom right of your screen here. So if you open the serial monitor, you can see a blank space here. Okay, this is the output of your serial monitor to be displayed by the Arduino, and you can put your input here if you are receiving any input from the serial if you are receiving any input from the from your outside peripheral or from your outside components or other platform. Okay, for example like your keyboard. Okay, so you can type here and you can send, and you click the button send here. So this data will be sent to your Arduino through your serial monitor port. Okay, the serial monitor port here is this USB port. Okay, so what you need to do is in your lab 1 but experiment number 3, so you can declare your serial port. Okay, to declare that one, we can declare it as serial begin, and then put the baud rate here. Okay, maybe this is okay. If you're not sure, okay, we can try simulate it. If there is an error, so this is an error. Okay, serial was not declared in the scope, so maybe it is using this one, capital S. Okay, we try again. Okay, now they are using capital S. Okay, so you have declared your serial port here. Okay, at the end of this coding, okay, I stop my simulation. At the end of this code, I would like to print something. For example, like I want to print, okay, dot print, okay, dot print something. I want to print something. Okay, let's say I want to print LED is blinking. Okay, so I start the simulation and I open my serial monitor. See, it is printed in my serial monitor, but it is printed it just printed all the way, okay, until the screen is until the end of the screen. Okay, there is no stop or break there. So what you need to do, you can improve your code. Okay, you stop the simulation. So you see here I'm using serial.print. Okay, to make an end line, you can put ln at your print. Okay, it means that it will print the enter at the end of your LED is blinking statement. Okay, now we see, we start the simulation again. What is the difference between this code and the previous one? So you see, so now my LED is blinking is printed with the end line. Okay, as if like you are using enter button here. Okay, alright, so if you want to clear your serial monitor, you can click on the clear button. Alright, so that is how serial monitor is used in this Tinkercad. It's actually almost similar to the real implementation or to the real-time lab that we should do. Okay, I hope the Tinkercad can help you to understand and improve your Arduino code and do the simulation as if like you are doing it in your in the control lab. Okay, so if you have any question on the Arduino code, you can always refer to Arduino website. Okay, you can always refer to this site. Okay, you can search here, for example, like cereal. Okay, Arduino cereal. There is a lot of example of coding example that has been shared by other programmer or developer. Okay, you can look into their code. Okay, or you can go to the reference if I'm not mistaken. Yeah. So you can see the function here. So you have a lot of function here. For example, I choose one function, cereal. Is there a cereal? Yeah, here, cereal. Okay, so in the cereal function, okay, see, you have a lot of cereal for function. For example, like just now I'm using cereal begin. So what is cereal begin? So serial begin is to set the data rate in bits per second for serial data transmission. So just now I use serial, this one. Okay, I use serial baud rate of 9600, but actually there's a lot of available baud rate, but the default one is 9600. Okay, just use 9600 only. Okay, so in Arduino Uno, there's only one serial port, and therefore you just use serial. Okay, like Mega, they have a lot of serial port, so they can rename the serial port. Okay, but for Arduino Uno, just using serial sahaja, right? Okay, then you have serial begin. Okay, what else? Okay, there is a lot. There's other function for example, like print. Okay, just now I'm using print, serial.print. Here, serial again. So print here. Okay, this is the difference between print and print ln. So print is just printing the data onto the serial monitor without any break or without any space. But if you're using a print ln, it will print your message along with the enter button. Okay, along with the new line. Okay, so that is the difference, right? So they will show you how to use this function in the Arduino Uno. So if you have any question on the coding of the Arduino, you can refer to this website, or you can just type in the Google how to do certain code. Alright? Okay. So hopefully I have made a clear guideline for you to start your first lab. Okay, hopefully that you can submit to me your first lab within the deadline. Okay, thank you.